Hey everybody, Mr. Judson here. So, don't look at that yet. We'll get there in a second. I want to go through two things that I didn't talk about yesterday, but that are important to us. Anytime you take the derivative of a number, this c always represents a constant, which is just a number. Anytime we take the derivative of a constant times a function, essentially we can move that constant out here and then say just take the derivative of the function. So the constant times whatever the derivative of that function is. That's kind of an important thing to remember. What it means is this: if I had something like 5 times x squared plus 2x minus 3, and I want to take the derivative, nice parenthesis, and I want to take the derivative of this, the derivative is really just going to be 5 times the derivative of this thing, 2x plus 2. And so then distribute your 5 and you get 10x minus 2. Could I have distributed the 5 first and had 5x squared plus 10x minus 15? Sure, I can do that. But sometimes you get something a little messier here, and you just want to think, okay, just write down the 5, and now let's figure out how to do that derivative. That's what this rule is saying. Okay? And then the second rule is saying if you're taking the derivative of two things that are being added or subtracted, or it could be 3 things or 4 things or however many, as long as we're adding and subtracting, you can take the derivative of each term by itself. You don't have to do it as a whole. And really, that's what we did with things like 3x to the 5th minus 4x squared. This is my f of x, this is my g of x. I can do the derivative of this first by itself, and then the derivative of this term by itself, and then the next term, and so on. That's what this rule is saying. But it's kind of one of those things that we want to make sure we understand so that moving forward, if that shows up, we know, oh yeah, we're adding and subtracting. We can break it up into 2 separate derivatives. All right, so yeah, you guys knew this was coming. Every time we learn something new, we need to go back and do that with trig as well. So what we need is, we need a shortcut that tells us what is the answer when I take the derivative of a sine of x. What's the answer? And so whenever we try to figure something like this out, remember I told you we always go back to our definition of a derivative? You know, what's that definition? F prime of x equals the limit, and I'll use h instead of delta x, as h approaches 0 of f of x plus h minus f of x all over h. Okay, that's the definition. Even though I told you we're all about shortcuts, and we want to be about shortcuts, we can't forget this. This is like the most important thing from this semester because everything depends on it. Without that rule, we're stuck. Okay? All right, so the derivative of this is going to be the limit as h approaches 0. I got to put an x plus h in place of this x. So what I get is sine of x plus h minus the original function, which is the sine of x, all over h. And now I got to figure out what this is equal to. Now, remember, you can't just distribute a trig function. You can't distribute any kind of function. Some of you guys tried that on a test. It didn't work. You have to use your sum and difference rules for the sign. Right? And you may not remember that, but I'll show you what it is. The limit as h approaches 0, when I'm adding 2 angles together, I have to do sine of the first, cosine of the second, plus switch those 2 angles. So I get sine of h cosine of x minus sine of x all over h. I have to make sure I expand this with the sum and difference rule. So in our book, you guys might remember our pre-calc book last year. If you open up the front cover, we had all this trig information right there that was helpful. It is in our electronic book, but what you have to do is, in the table of contents, you have to go all the way to the bottom. It's like the last 4 pages. And so when you do that, see if I can, yeah, there we go. So we've got a bunch of algebra information. There's our quadratic formula, how to factor, some of those special factoring things that we should know. Factoring by grouping, we did that last year. Trying to think what else is in here that's important. Here's some geometry stuff, some formulas. We're going to have to know some of this stuff, how to find the volume of a cone or a sphere at some point. But here's all of our trig stuff, right? There's the unit circle. If you guys wanted a good unit circle available, use your snipping tool, which is on your computer, and snip a picture of this and then print it out. That's a good picture right there because it's got all the information in it. But here's our sum and difference rules, right? Sine of u plus v, it says right here how you convert that, or cosine. So we want to make sure we remember those things. I know it's easy to forget, especially if you're not using them all the time. But we want to remember that so that when we expand things, we're doing it the right way. I don't know what this last page is. Oh, yeah. Oh, boy. Somebody asked me, how many tests do we take? And I forgot about this one. At some point in time, we will take a test over all of these formulas. These are all the derivatives we're going to learn this semester. Not these ones that have these h's in them. Okay? So only the first 24. Only. And then all these integration formulas, we learn about integrals next semester. But we're going to have one test over this page. All the formulas. Why do I do that to you guys? Simple. I found that students won't memorize this unless they have a test on it. So we're going to have a test because it's important to know all these formulas if you're going to get through calculus. All right? So yeah, you might wish I didn't just show you that. All right, let's get back to our problem here. So I'm trying to figure out what the derivative of a sine is, and this is what we've got so far. All right, so what I'm going to do is I'm just going to switch these two terms, and so I'm going to write this. I've got the limit as h approaches 0 of sine of h cosine of x, and then plus, and I'm switching this over to here because I kind of want to group it with that term. Sine of x cosine of h minus sine of x all over h. By the way, this h that you see here is not the same as the h that was on that formula sheet. It means something totally different. They're called hyperbolic trig functions. I don't even remember what that means, okay? This is just an angle, right? So not the same thing. And then what I'm going to do is I'm going to divide this into two separate fractions. The limit as h approaches 0 of sine h cosine of x over h plus this fraction sine x cosine h minus a sine of x all over h. And at this point we should start to recognize something that's helpful. Remember if we do the limit as x approaches 0 of sine x over x, what we said is as long as these two things are the same, that gives us something important. It's one of those special limits. So I'm going to write this one more time, a little bit different. The limit as h approaches 0 of sine h over h times cosine of x plus, this limit goes with that as well. So the limit as h approaches 0. And what I'm going to do is I'm going to factor a sine of x out of each of those. So a sine of x times cosine h minus 1 all over h. And I'm purposely writing that h over here because, again, this is really close to one of our special limits, right? So when I look at this limit is equal to 1. I'm not plugging anything in here because it says as h goes to 0, not x. So I get 1 times the cosine of x. And over here, this isn't exactly right. It's supposed to say 1 minus the cosine of h. Well, if I factor a negative sign out here, then I would have what I want. This would become negative, this would become positive, right? So what I would get is I would get a negative sign of x times the limit as, remember this is now, let me just write this down, this is now 1 minus cosine of h, and I factored a negative sign out. This whole thing now equals 0. The limit as h goes to 0, it's one of our special limits. And so, let's see, 1 times cosine x, that would be just a cosine of x. 0 times anything is 0. So there's our answer. I don't ever want to do this again. Because I now know the answer, I have a shortcut. The derivative of a sine of x is equal to a cosine of x. That's it. You can go through this whole process if you want to, but I sure wouldn't. We know what the answer is. It's always going to be the same. Why go through this over and over again? There's our shortcut. And so our next question now, of course, is, all right, so if I do the derivative of a cosine of x, well, let's see, if the derivative of sine equals the cosine, well then the derivative of cosine must equal, you said sine, didn't you? Wrong. Close. Negative sine of x. So why is that one negative and the other one isn't? Let me go back to our trig stuff. When you expand something with a cosine, you do the opposite over here. Okay, this is, let me make this bigger. When you expand the cosine, if this says cosine of u plus v, then over here you're choosing the opposite sign. You're choosing a negative when this is positive. You're choosing a positive when this is negative. That's what creates that opposite. So yeah, if we went through and tried to prove this the same way we just did this one, because in our sum and difference formula, so right here, if this was a cosine, when I write this down, I need to put the opposite sign here that was there. And that's where the negative comes from. Okay? I'm not going to go through and prove that. I'll kind of let you guys do that on your own if you'd like, or you can look it up on YouTube. You know, proof for the derivative of a cosine. And you can watch somebody work it out and have them explain it to you. But again, we are all about shortcuts, and there's our shortcuts. Okay? That's what I want to work with from now on. All right, let's do a practice problem. All right, so y equals 2 sine of x, and they want us to find the slope of the tangent line at x equals pi over 6. Since we now know how to do the derivative of a trig function, you guys should be able to handle this. You guys go ahead and try. All right, so y prime, I've got a constant times a function. So the derivative is just 2 times the derivative of that. And the derivative of a sine of x is a cosine of x. So what's the slope of the tangent line? Y prime at pi over 6 is equal to 2 times the cosine of pi over 6. Pi over 6 is right there, right? What's the cosine? That's the x-coordinate. That would be that value right there. That does not look like the halfway point, so it must be root 3 over 2. So 2 times root 3 over 2. 2's cancel, and I get the square root of 3. You know, if you start thinking, okay, rise over run, what does that mean? Well, I don't know. I'd have to go figure out what the square root of 3 is, and I'm going up that decimal amount and over 1. That would be my slope for that tangent line. But this is all I need. There's my answer. Let's try another one. D over dx of the sine of x over 2. That means find the derivative of the sine of x over 2 with respect to x. For right now, we want this variable to always match what we're using here. If I said find d over dx of sine of t over 2, we'd go, oh boy, I can't do that. The variables don't match. We're going to have to deal with that later, but for right now, that's not going to happen. Okay? You guys try it. So if you're sitting there going, this seems kind of easy, well, yeah, it is. If we know the shortcut, right? So this would be the same as saying 1/2 times the sine of x. So I've got a number times a function. So the derivative is that number times the derivative of sine of x, which we know is cosine of x. And you can leave it like that, or you can say that's the same as cosine x over 2. Either one of those is a good answer. All right, one more. All right, so what I have here is y equals x plus cosine of x, and we want to find the equation of the tangent line at x equals pi. Not the slope, but the actual equation. Right? Whenever we find an equation of a line, it's always y equals mx plus b as our final answer. You guys try it. All right, so equation of a line, I need 2 things. I need a slope and a point. So let's find a point first. Y at pi is going to equal pi plus cosine of pi. So on the unit circle, pi is right here. The value of the cosine is the x-coordinate, so that would be -1. So what I have is pi minus 1. So my point is pi comma pi minus 1. 3.14 comma 2.14. Okay, if I was writing out in decimal form. But I'm going to leave it in exact form, so I'll just leave it like that for right now. Okay, now I need my derivative to find the slope. So derivative of x is 1. Derivative of a cosine of x is a negative sine of x. And so now I want to know what's the derivative at pi. So y prime equals 1 minus the sine of pi. So, you know, again, the sine is the y-coordinate. What's my y-coordinate right here? It's going to be 0. So this is just 1 minus 0, which is 1. There's my slope. So I've got a point and I've got a slope. Now I just need to write the equation. So y minus the y value equals the slope times x minus the x value. Keep this in mind, on the AP test, if you were to take it, and you had to write out the equation of a tangent line, you could stop right here. Because the AP test has a rule that you don't have to simplify. The problem you run into is, if it's a multiple choice question, you won't see this as an answer. They'll simplify it and give you a y equals mx plus b type answer. So we do have to make sure we keep those skills up. So what I've got here is y minus pi plus 1 equals x minus pi. If I want to get y by itself, when I move this pi over and add it, that adds up to 0, so those are both gone. When I move the 1 over and subtract it, I get x minus 1. There's the equation of my tangent line. And so again, if I want to check this and see if I'm doing things right, you guys, I think this is so important, having that mindset that I really want to know if it's right. As opposed to, well, I think it's right. I'm good. Let's move on. Let's get the next one done. I don't have time. I think that curiosity needs to be there. And so to go and graph it, the original function, I want to graph that. I want to graph this. Once I do that, I want to find that point where this line comes and hits the curve. Is it at 3.14, comma 2.14? And if I was able to see that on my calculator, then I would think to myself, yeah, I think I did things right. Okay. That's really all we have for today, but I want to let you guys know that it's a lot more complicated than this. Like, for example, what's the derivative of a tangent, or a secant, or a cotangent? We can't do that yet because, remember I told you, if you don't know what to do, change the sines and cosines. Well, if y equals sine divided by cosine, now all of a sudden I'm dividing things, whole different story. It's coming soon. We'll probably get there, we'll get there next week. But it's not as simple as what we just saw with the sine and cosine. It's a little more complicated. To make matters even worse, what if I said this? Y equals the sine of x squared plus 2x. What makes the sine and cosine easy right now is our angle is just x, or just theta. It's just one variable. You put something like this in there, just made everything more complicated. The derivative of this is not the cosine of x squared plus 2x. Once our angles get messy, there's more work that we have to do. So we're not going to worry about that today, but I just want you to know everything's not as easy as what we just saw. Right? It'll get a little more complicated. I don't think it's bad, but it's going to get a little more complicated. Okay. All right, that's what we have for today. So let me get you guys an assignment. All right, so here's what we've got. We've got number 7 continued. This is our last day, Thursday. Page 118. We're going to do 23 to 26, 37, 38, 51 to 54, and 63. Some of these just ask you to find the derivative. They should go really fast. Shouldn't take a long time. Some will say, what's the slope of the tangent line? All right, takes a little bit longer. I got to find the derivative and plug a number in. And some will say, find the equation of the tangent line. And so it'll take a little more time. But I think overall this won't be bad because we only have 2 trig functions so far to work with. All right, you guys have a good weekend. I'll see you on Monday. Take care, stay safe.